When we were discussing the characteristics of data structures, we said that some of them are dynamic and some of them are static, depending on whether the size of the data structure can change or it is set to a particular value from the very beginning. When we talked about arrays, we said that they are an example of a static data structure. We declare the size of the array upon creation, and after that we can do nothing to change it. The ArrayList class provides to us a kind of array that is dynamic. The array can automatically grow, we don't even have to specify and say increase size, to the size that we need. The ArrayList class is not a class that we have to write, it is already provided to us through the java.utils package. So remember to import this package whenever you want to use an ArrayList. The ArrayList works with all kinds of objects. However, we need to specify from the beginning, when we declare the ArrayList, what kind of objects will be stored in this ArrayList. Here is an example of how we declare a variable that is of an ArrayList type and how we create the ArrayList itself. The line that you see on your slide defines an ArrayList of strings in particular, and it creates an empty array of strings. The ArrayList class is an example of a generic class. Generics is a topic that we have not touched yet, but will be covered more fully later. A generic class is a class that we can be parameterized with another class. In this particular instance that we're talking about, the ArrayList E is parameterized with the type E. That means that the ArrayList can only hold elements that are references to objects of type E. E must be a reference type. This is a constraint for the ArrayList. It cannot be a primitive type. Is this a big problem? ArrayList cannot hold primitive types, elements of a primitive type, but only references. For example, we cannot say ArrayList int list. This will not compile. However, we can use the wrapper classes in order to indirectly store primitive values, because we can say ArrayList integer list, and to our good luck, Java actually automatically handles the conversion between a wrapper class and the corresponding primitive type. So there is a way to use ArrayLists with primitive types. It is just an indirect way through the use of a wrapper class. ArrayList has many useful methods, many methods that make it possible for us to access items, add items, and so forth. This is one of the add methods that it supports, and it will add the element E at the end of the list, or we can specify at which particular index to add the element E, and like usual, index numbering starts from 0. There is also a contains method which will tell us whether or not a particular element is in the list. Get I will return the element that is at index position I. Remove E will remove the element E from the list. Notice that E is not the index, but it is the element itself. Finally, size is similar to the length method of arrays. Size will give us the current size of the list. Here is an example program where we can see the use of some of the ArrayList methods. Notice that, as we mentioned, we need to import the ArrayList from its package in order to be able to use it in our class. In this particular example, we have also imported the scanner class from the java.util package, because as you will see, we will be reading input from the user from the keyboard. The first line inside the main method of our program creates a new ArrayList of strings. the array list is currently empty, it is ready to accept elements. And this is what happens inside the loop, the while loop. While the user has more lines, inputs more lines to us, we read a whole line that the user inputs, and then we add it, we store it into the array list with list.addS. Finally, after the user has input all of the lines that the user wished, we can print how many lines we have actually stored, and that will be the size of the list, because notice we store line after line at each position of the array list. So the size of the list will give us the number of lines that the user gave us. Finally, we can use the list.size in order to create a definite loop, a for loop, and then print each of the lines that we read from the user by list.get at position I. One more example about the use of the array list, which will actually show us an interesting way to write for loops with the array list. So if you spend some time, you will be able to follow exactly what the program does. We create a new array list of 3 objects this time. If you don't remember, you can take a look at the 3 class that we have written in previous examples so that you can become more familiar with its methods and fields. Inside the while loop, we just create new 3 objects with random circumference. We are using the math.random method. We are adding each of those trees to the array list, and then we use the static field, the get number of trees of the tree class, to print how many trees we have just created. We are also double checking that this is exactly the same value as we get from the size of the list. When we print those 2 numbers, those should be exactly the same. Probably the most important part of this program is at the very end, where we have written a for each loop that goes through all of the elements of the array list and prints a specific characteristic of each of the trees. We invoke the getRadius method of every tree object stored in the array list, and we print the radius. This is the main point that you need to hold from this example, the use of the for each with the array list.